Hello everyone. In this video, we are going to prove the sum and differences of trigonometric identities. That means we are going to prove what is cos of x plus y equal to, what is sine of x plus y is equal to, and when it comes to the differences like cos of x minus y equal to how it is going to be, and sine of x minus y how it is going to be. Not only that, we are going to prove few complementary angles, that is sine of 90 minus x, or cos of 90 minus x, or tan of 90 minus x, or plus x. What happens with those results? Regarding that only we would be seeing in this video. So let's start. The first one, cos of x plus y is equal to cos x cos y minus sin x sin y. How to prove it? We are going to take a help of a unit circle. A unit circle means we are very much aware the radius is going to be equal to 1. Okay. Now, what about the coordinates in the unit circle? Now, let me just explain it about the coordinates of a unit circle now. So, see here, if I have a circle, which is a unit circle, so in that case, if I have a point here, P, this particular point P coordinate, what is that gonna be? So let me just explain it to you how that works. Now I'm having a center O here. I know this doesn't look like a center, but kindly bear with me. Now we have P here, okay, OP. Since it is a unit circle, OP is gonna be equal to 1. Done. Now, here we have, let me make a perpendicular. When I'm drawing a perpendicular here, and if I consider this to be theta, okay? So now, what is my sine theta is gonna be? Sine theta is equal to opposite side, which is PM divided by hypotenuse. So now, what happens? Sine theta is equal to PM. That is what it means. So PM is getting replaced by sine theta. Okay. Okay. Then what is going to be my OM? Cos theta is equal to adjacent side, which is OM, by hypotenuse, which is again 1. So cos theta is equal to OM. Okay. So that means OM is going to be equal to cos theta. That means this particular distance is cos theta. Then this particular distance is sine theta. Now, in that case, what is gonna be my coordinate here, P? P is gonna be x comma y, am I right? What is my x? Cos theta is my x, and then sine theta is my y. So that is gonna be my coordinate. Always in a unit circle, our coordinate is gonna be cos theta, comma sine theta. That's been done. So now let me start with this particular circle which I have taken, and let me erase this part. Now, let me go ahead now. Now, guys, we have P1 here. P1 lies on a circle and that too on a unit circle. Then the angle which it is getting formed here is x. So my coordinate of P1 is gonna be cos x, comma, y coordinate is sine. So it's gonna be sine x. Since the angle is x, we got it. Now, let's come to the coordinate of P2. Okay. So now let's have a check with the angle here. Here, the angle which I have is x till here, and then I have y till here. Totally, it is x plus y. So I would be having cos of x plus y, and then sine of x plus y. Okay, that's gonna be the angle here. And then now let's come back to P3. P3 here has an angle of minus y. Then how my coordinate is going to be? Cos of minus y, and then comma sine of minus y. Done with our coordinate. Now one more point is there. What is that? That's P4. P4 lies exactly on the x-axis. Since it lies on x-axis, what is going to be my y coordinate? 0. And what about my x coordinate? The x coordinate is going to be equal to 1 because it's a unit circle. And if O is a center, then OP is going to be equal to 1. OP4 is equal to 1. So now we are done with our coordinates we have. Now, okay, I think you are able to observe we are having two triangles which is getting formed here. One is, let me just put a dot here, O, P1, and then P3. This is one triangle which is getting formed. And then the another one I'm marking with the green dots. That is again with O, and then P2 and P4. These two triangles, I'm gonna check the congruency of those two triangles. Since both the triangles, when we are proving, it would be congruent. Let's prove the congruency first and let me come back to the next one. So now here, consider, consider triangle OP1, P3 and triangle OP2, P4. I would say that OP1 is equal to OP2 and then OP3 is equal to OP4. Why is that? Both are equal. The reason is only one reason because they are radius. And our radius is equal to 1 because it's a unit circle. The radius is always going to be same. That's the reason these two are equal. Not only that, I would be saying this particular angle is there, right? That is angle P1O P3 is equal to angle P2O P4. These two are angles are also equal. Since side, angle, side, that is what? Through SAS congruency. Both are congruent. So triangle OP1, P3 is congruent to triangle OP2, P4. Done? Now, by corresponding parts of congruent triangles, that is by CP, corresponding parts of congruent triangles, I can say that P1, P3 is equal to P2, P4. That means what I wanted to convey is this particular side, what you have, is equal to this particular side. Now, how to find out the distance of those two sides? Since we are saying equal, okay. How to find out the distance of it? We have a distance formula. Our distance formula comes something like this. Okay, if I have to find a distance of AB when A has been given, B has been given with the coordinates. Suppose here I have x comma y, and then here I have, okay, let me keep it as x1, y1, and x2, y2. The coordinate has been given. How the distance formula we would be writing? AB squared is equal to, we would be writing like x2 minus x1 the whole square plus y2 minus y1 the whole square. This is what we do. So here x2 minus x1 the whole square plus y2 minus y1 the whole square. And whatever way you take, it works because anyhow we are going to square it. Okay, whether it's x1 minus x2 or y1 minus y2 the whole square, that doesn't matter because anyhow we are going to square it. That's the reason. Okay, we would be generally writing AB is equal to root of, but I'm not going to go for root now because my motto is not that actually here. So let's go with the distance formula. So I would be saying P1, P3 square is equal to. So we have, see, what is our P1 cos x sin x? What is my P3? It is cos of minus y and sine of minus y. That is my P3. So now see, x2 minus x1 or x1 minus x2 both would work, I said. So I'm just going with x1 minus x2. So I would be writing it as cos x minus cos of minus y the whole square plus sin x, that is y1, minus sine of minus y the whole square, that is my y2. Done? So now if I square it, see, First of all, before squaring, let's do a small work which we need to do. See, we have learned in the previous video what is that? Cos of minus y. It's an even function, so my result is also going to be positive. So let me just rewrite it. It's going to be cos x minus cos y the whole square. Whereas when I have negative of sine of negative y, it is going to be minus sine y, that minus would get multiplied with this one. So it becomes plus sine y the whole square. See, this one is equal to sine of minus y is equal to minus sine y. And this minus would be getting multiplied with this minus, it becomes plus. That's how it works. Now, we are going to expand it using a minus b the whole square formula and a plus b the whole square formula. So that is what we are going to do. So now when I do that, I would be getting here cos square x plus cos square y and then minus 2 cos x cos y. And then this side, when I do it, I would be getting sine square x plus sine square y and then plus 2 sine x sine y. Great. Now, if you just observe, we have cos square x and then sine square x. Both when I add sine square plus cos square, it's going to be 1. Okay. And then we have cos square y and then sine square y. When I add these two, I would be getting 1. So now let me do the changes now. So I'm having 1 plus 1 and then minus 2 cos x cos y and then plus 2 sine x sine y. So this is equal to 2 times minus 2 cos x cos y plus 2 sine x sine y. This is what I have got. Now let's keep it aside for some time because we need to do the other one, distance. We found out P1, P3 square. Now we are going to do P2, P4 square. Okay. Now let's just expand P2, P4 square using the distance formula. So now we have P2, P4 square is equal to, now, what are the coordinates of P2? It is cos x plus y and sin x plus y. And coordinates of P4 is 1, 0. Now, let me just go ahead and expand it. Now, when I do that, as per the distance formula, when I write, I would be getting 1 minus cos of x plus y. Okay, this time I'm taking x2 minus x1 the whole square. Last time I did it the other way. So I'm just saying this again and again because both are same since we are squaring it. That's the reason. And then here plus y2. It is 0 minus sine of x plus y. The whole square. Now here when I expand using my a minus b whole square identity, what I would be getting here is 1 minus 2 times cos of x plus y and then plus cos square of x plus y done. And then here I would be getting just like that because the minus whole square becomes positive. So sine square of x plus y. This is what I would be getting. Now here if you observe, you have cos square x plus y plus sine square x plus y which is equal to 1. So in that case, I have 2 minus 2 times cos of x plus y. Great, I got this. Now, see here. We have found out P1, P3 is equal to P2, P4, right? But we don't have like P1, P3 square is equal to that. But see, generally, when without a square something is equal, even after squaring it is going to be equal only. So that logic only we are going to work here. Okay, very simple concept. When you say that P1, P3 is equal to P2, P4, Then if I'm squaring both the sides, even that has to be equal. So on that logic, we are proving it. So that means P1, P3, the whole square is equal to P2, P4, the whole square. Now, on that basis, I'm going to equate this one, 1 and then 2. When I equate, I would be getting, I'm sorry, instead of keeping this one would be 1. Okay, then in that case, I'm having 2 minus 2 times. I'm taking common. I have cos x, cos y. I'm taking minus 2 as common. And then minus sine x, sine y is equal to 2 minus 2 times cos of x plus y. Okay, this plus 2 and this plus 2 gets cancelled. And even this minus 2 and this minus 2 gets cancelled. And you are left out with our identity which we wanted to prove. Cos of x plus y is equal to cos x plus cos y minus sin x sin y. That's it. We proved it. Hence the proof. Okay. So now we will move on with the next one. Cos of x minus y. Okay, is equal to. I'm not going to prove it using the same procedure. I'm going to do very simple things since we proved this already, this one. I'm going to take a help from that. What I'm going to do here is I'm going to replace my y by minus y in the one which I proved just now. So what I would be doing here is just replacing y, that is plus y. I'm going to replace it by minus y in my cos of x plus y formula. When I do that, I would be getting cos of x plus minus y. You're getting? So that is where I'm doing it. I'm using the same formula which I proved just now. I'm taking the help of it, but I'm replacing plus y by minus y. In that case, since I proved it, the same thing, what would happen? I would be getting cos x. Okay. And then, I'm sorry, it is cos x cos y. And then cos of minus y. And then minus, okay, sin x. And then sine of minus y. And we are very much aware about the odd and even functions. Cos of minus y is going to be equal to cos y because cos is an even function, whereas sine of minus y is going to be equal to minus sine y because sine is an odd function. So I'm going to work with that. Now here I would be getting cos x, cos y, cool. And then minus, I would be getting sine x and then minus of sine y. Wow. This minus and this minus both would be getting multiplied and I would be getting a positive and the result is going to be cos x cos y and then plus sin x sin y. It's going to be equal to cos of x minus y. That's it. We proved it. Quite simple. This is how these two formulas we have proved. Now the next one, we are going with the complementary before going to the sum and difference using sine of x plus y and sine of x minus y. Before proving that, we are going to look into complementary formulas. 90, right? When we say that it's a complement, we say that already. Supplement means 180, complement means 90 degree. There itself it has come. Now see here, we have cos of 90 minus x. How to prove this? It is in the format of cos of x minus y. We have just now proved that formula. I'm going to take a help of that. So here, what I would be doing here is cos of pi by 2 minus x is equal to, I would be expanding as per the formula which I proved just now. I would be getting cos pi by 2, then cos x plus sine pi by 2 and then sine x. That's it. Now, what is cos pi by 2 value? Cos pi by 2 value. And what is sine pi by 2 value? Cos pi by 2 is going to be equal to 0. So, 0 is getting multiplied with cos x. And then sine pi by 2 is 1. 1 is getting multiplied by sine x. Now what happens? My result is going to be just sine x because 0 multiplied by anything is going to be 0. 1 multiplied by a number, I would be getting the same. So cos of pi by 2 minus x is equal to sine x. Done with this proof? Now in a similar way, we have sine of pi by 2 minus x. Now you would be thinking, we never studied anything with difference of sign formulas, but still we have something here. Now actually I'm going to take an help of my previous identity which we proved just now. See, cos of pi by 2 minus theta or some angle is becoming a sine of that particular angle. So now if I have sine of, so I'm going to take a help here. See here, if I have sine of pi by 2, that is 90 minus x, I can also write it as cos of pi by 2 minus pi by 2 minus x, which is obviously I'm using, and that's what I said, I'm taking a help of the previous one which I proved here. I'm taking the same logic. So 90 minus of that angle is going to be giving me sine of that. So I'm done. So now here again, which one I would be using? I would be using cos of a minus b again. So let me expand it. So when we expand it, you would be getting, okay, cos pi by 2 and then cos of pi by 2 minus x. Great. And then plus sine pi by 2 and then sine of pi by 2 minus x. Great. Okay. Now, what is cos pi by 2? Cos pi by 2 is 0. So, 0 multiplied by any of this is going to be 0. Okay. Then, sine pi by 2 is 1 times of sine of pi by 2 minus x. Sine of pi by 2 minus x. See, this is going to be equal to cos x. That's it. We could have just written here itself, but since you guys didn't learn the complementary concept, that's the reason we did this. Sine of 90 minus x is going to be equal to cos x. So we have done with that. Okay. Now let's come back to this particular proof which we have. Sine of x plus y and sine of x minus y. Something very important one, like as we did earlier. So now, sine of x plus y. Okay. So how to do that? I would be taking in help of cos which we proved just now. So it's gonna be cos of pi by 2, then minus of x plus y. Okay. Cos of 90 minus theta is equal to sine theta. It works. Okay. Now you expand this one. When you expand this one, before that, you just write it in this way. Cos of pi by 2 minus x. Okay. And then minus x, and then here minus into plus is going to be minus y. Say cos of a minus b. I've split that. So now let's expand it based on that. So when I do the expansion, I would be getting cos of pi by 2 minus x cos y. So cos x minus cos y is equal to cos x cos y plus sin x sin y. So based on that, I would be doing the expansion. So here cos y and then plus sine of pi by 2 minus x and then sine y. Done. Now after this, what is cos of pi by 2 minus x? It is nothing but sine x cos y And then sine of pi by 2 minus x is cos x sine y. That's it. We have done with the proof of sine of x plus y. So sine of x plus y is equal to. Now in the same way, we would be just replacing y by minus y. Then in that case, in my previous formula, it is the above one. So in that case, I would be having sine of x plus minus y is equal to, apply it in this formula, I would be having sine x cos of minus y plus cos x sine of minus y. Done? Now we know cos is an even function, so negative would be, the result would be positive, so sine x cos y. And then here we have sine of minus y, which is a odd function, so I would be having minus cos x sine y is equal to sine of x minus y. So I've done with most of the proofs of sums and differences under trigonometric, and even few complementary angles has been covered here. So using this logic only, we have problems also, and few more I think identities are left out. There's like tan of x plus y, tan of x minus y. So and then cot of x plus y and cot of x minus y, and we have double angle formulas and all. So regarding that, we would be looking in the next video. Thank you.